Okay, so we are next looking at the third example. So the third example is we are using the dictionary API in combination with the jobs API, the USA Jobs API. Specifically, the two APIs are going to function asynchronously. Okay, so essentially, both APIs will sort of race each other to see who can finish first. And because they're running asynchronously, there's no guarantee on which API finishes first. The dictionary API could finish first, or the USA Jobs API could finish first. And we have to, as we're building this program, we have to account for that. Okay, so everything is roughly the same up until the request handler. Okay, over here we get new requests from the IP address for a particular resource. If the resource is the root of the site, then we're going to send back this index file. Okay, and so this index file itself, it takes in two pieces of information. The first one is indexed by the property name property name description. Okay, so this is the job description. And just one additional assumption that we're going to make, because we're going to use this description field as the sort of shared field between USA Jobs and the dictionary API. We're going to assume that the job description is going to be a single word. For example, doctor or programmer, and not something like software engineer. That's two words. Just because the dictionary API won't recognize two words. Okay, so we'll assume that this is a singular word. And the location is used by the USA Jobs API to refer to the location in where this job should be located. Okay, so just like before, user input is, so we catch that, so we fill out the form, it gets caught over here on the search endpoint. The data that we get passed in is a URL params object, which is a hash map. So we can use the get on the description and location to extract out those two values. Over here next we use res.writehead to tell the browser what to expect. In this case, expect text/HTML. And then we're going to call the get information function, which this function is used to make two API calls. And again, it's really important to note that this is operating asynchronously. Okay, so meaning that there's no guarantee on order. So essentially, once we get to, well, let's go through this function first. So that it passes in the two input parameters, description and location, as well as the res, which is the response, our link to the response. And then we have, let's see, we have two endpoints, USA Jobs endpoint and the dictionary endpoints referring to each one. So the actual call to https.requests, because this doesn't actually send out the request right away, and at least not until we call the end function. This is not the asynchronous component. Okay, so we're just setting up the request right now, which essentially says that when this request gets made, it's going to go to this endpoint over here, usajobs.gov/API/search keywords and so on. We're going to supply it the credentials, which is the API key, as well as your email when you use to sign up for the USA Jobs website. That goes into the header. And on the dictionary endpoint, this one is sort of fully public. You don't need API keys or anything. There's no authentication attached to it, so you can just query that endpoint with, in this case, the description. Options we'll come back to, but essentially this is going to be acting as a counter because we're operating asynchronously. It's important to note that if you're doing something like your final projects where you need to do a task synchronously, that is sequentially, then you don't need this counter. Okay, meaning that if you are forced to do task A then task B, then after task B you can continue the program. You can continue the execution of the program. If you have a task C afterwards, you can do that. Now, if task A and task B are being done concurrently, okay, so sort of side by side in parallel, then essentially I don't know which one finishes first or second. And so the only way that I can keep track of when to move on to the next stage is if both of them have completed. And that's what this task completed counter is used for. Okay, but the specific syntax that I chose, we'll come back to this. Okay, so over here we attached two event listers on the response event. You can use on or once, it doesn't matter in this case because the response only transmits once. So in this case, the dictionary request on when I get a response, I'm going to take that that stream. So the data type is actually incoming message, and I'm going to pass it to the function process stream, which we know already takes a stream and then converts it to essentially a string in this case, one chunk at a time. So it takes a stream of data and it sort of parses it one chunk at a time, attaches it to body. When there's no more data, we get an end event. Then an event in this case will call the callback, which was applied in as the second parameter. We pass into that callback the combined string body, as well as any additional arguments that we want to pass forward. So in this case, for the dictionary API, when we process the response stream, we're going, once we finish converting it to a large string, we're going to pass that to the function parse dictionary, which is down here. And in fact, this is the one that we should have, right? So parse dictionary, as well as supplying it this options variable, which is our counter, as well as the response objects. This is the function that asynchronously sends the request off. Everything up until previously is actually just procedurally accomplished because we're just setting stuff up. This is where we send off the requests, dictionary.request.end. Over here we're setting up another listener on the USA jobs endpoint, and then over here we have an asynchronous call. So dictionary is called first and then USA jobs, but both of these get placed into the task queue, and then each, oh, sorry about that. And then each right, and then so each one goes into the task queue. A worker thread will pick them up. Okay, we'll pick up each one, and then the each worker thread will work as fast as it can to parse. So at that point, there's no guarantee on which one finishes. Okay, so essentially one of these two is going to finish first, either USA jobs or dictionary, and then when they finish, they're going to call process stream. Okay, well, they're going to call this function, which is an arrow function that calls process stream. Process stream, upon completion, will call parse dictionary or parse USA jobs. So essentially we can sort of think about these two operating concurrently, these two functions, parse dictionary and parse USA jobs. Parse USA jobs, for the most part, is the same as the previous demo. We get the jobs data. So we'll talk about this counter, this options counter, but everything else is roughly the same. Okay, so we get this job data, we parse it, we get this job object. One thing that I should sort of caveat is we have this ampersand notation, and this is sort of like the older notation before the optional chaining. And so you might see this, but we can simplify this nowadays because we have the optional chaining. But if maybe you're using a really old version of Node, I think prior to Node version 14, this wasn't available. And this was sort of the alternative, which you can see is kind of messy, where you have to say job objects and job objects.search result. So essentially this is doing like short circuiting. So if this one turned out to be like undefined or something, then it wouldn't do any of the rest. But it looks like a very dirty hack. So optional chaining is the preferred way if you have that. available, which we do. Okay, and this is a much cleaner syntax, such that if even one of these is undefined or null, then it'll just stop parsing the rest. So that's going to be jobs. We're going to map this function over here to extract out the information, and then we're going to join it all together. Okay, let's see. The results itself is just formatting. So the key important change is going to be this line over here. Res.write results. There's a pad end on it, and then it calls terminate, and passing in the options in the res. Okay, so both parse USA jobs and parse dictionary have a call to this function. Okay, so you can both see that they have a call to this function. And what? Okay, so first let's look at this function. So it essentially calls a res.write, and then upon completing the res.write, it calls this function terminate. Okay, so we know res.write essentially will write data. Okay, now if we look at the sort of previous examples, okay, we look at the previous examples of this, then we can see that we use res.end instead of res.write after we parse the results. Okay, and in this case we use res.write in both scenarios. Okay, so both in USA jobs and in parse dictionary. Okay, and the reason why we use res.write is if we use res.end, that sends a four-way closing handshake. Okay, so that sends a four-way closing handshake, and the problem with that is we don't know whether parse dictionary or parse USA jobs finishes first. Now, if you do know, if you have that synchronous guarantee, then you feel free to use res.end. But in this case, we don't know which one finishes first. And if let's say dictionary finishes first, if dictionary finishes first and I put res.end, okay, then that prevents USA jobs from finishing correctly, because over here it's gonna try to write, but the client is going to complain that you already sent a four-way closing handshake, so you can't sort of write anymore because you closed the socket. And this also applies vice versa. If parsed USA jobs use res.end and this one turned out to be faster, then it would prevent parse dictionary from executing because it would try to do res.write on something that was closed. So how do we sort of get over this hump? So to get over this hump, essentially we have both parse USA jobs and parse dictionary to both use res.write. Now this creates a new problem that you never close the socket, you never close the communication. Okay, so you need to, before the user can start processing the data, you have to send them an end event. Okay, so if you just use res.write, essentially that leaves the socket open, which means that the user is going to continue waiting for more data. Okay, so that's where this terminate function comes into play. Okay, so terminate is this function down here that takes in two parameters, options and response. And what it does essentially is it counts the task completed. Okay, so that was our variable all the way up here, task completed. So task complete, we have this variable options, which inside of it has a variable task completed, which has the number 0 inside of it, which is a bit of a roundabout way to do it, but I'll explain sort of why we need it this way. So this increases that counter by 1, and if the counter, in this case options.task completed, ever reaches 2, then we know that both the parse USA jobs and the parse dictionary function were both called, because over here we only call it once. Okay, we call it terminate once, and then over here we call terminate once. So if at any point in time we call both, if at any time that this variable becomes 2, that means both of these have been called. That is, parse USA jobs and parse dictionary have both been called. So that's the little trick that is used. We have this sort of counter over here. So we have this counter options, okay, that we pass into both the dictionary and the USA jobs, but it's a shared variable because it was declared inside of the function get information. Okay, so the question is sort of, why did I use this weird sort of shape? Why not just say options is equal to 0 or something? Well, and that's because inside of JavaScript, objects, like the one over here, are passed by reference. And if you just use a pure value, like 0, like if I said options is equal to 0, then that is passed by value. So it makes a copy of it, which defeats the purpose. Okay, so that is, I want this option variable to be the same option variable shared between both dictionary request and USA jobs request. So that's why we have this object wrapper over here. And this is another very common sort of JavaScript pattern, to have this wrapper over some counter that you want shared. The other option, of course, is to just create a global variable, which is very bad practice, so we try to avoid that. Okay, so right, so each of these uses res.write, and then it calls the terminate function, which counts how many calls to it was made. When that count reaches 2, then we use res.end. And again, this is, I see this on sort of final project submissions very often. If you're doing a synchronous project, which you are, you don't need this terminate function. Okay, this terminate function again is used by asynchronous development, because in that scenario, you don't know which one should call the res.end. If you're building a synchronous application, then you know you have to do A before B, so B should be the one that calls res.end. Or some function after B should be the one that calls res.end. Let's see. Okay, so parse dictionary. This is pretty much the same as before in the first example. Again, the main change is that we use res.write instead of res.end. So one last note. This is not a big deal, but essentially, when you're working with a browser, it has, so it'll do some rendering, some pre-rendering, if only if it's received enough data. So typically it's at least like 1,000 characters or so. So in this case, some of them could possibly, specifically the dictionary most likely, could have fewer than that number of character code. So I'm going to just pad it on with spaces. That way I can always force a force the browser to display the results early. Okay, so specifically, we're forcing the browser to render a sort of partial response because it has the feature, I believe it's called transfer encoding chunked. Okay, so we don't really need to set this parameter, and Firefox and I believe Chrome will do it if it's the right size. Okay, so let's run this. Okay, so first localhost. Okay, so localhost 3000, and do I have a timeline here? I guess that's fine. Okay, so we'll use Firefighter in New York because it's already pre-filled. Okay. So this default one that I have, I don't think I saved, that's why. So this default one that I just showed was actually this code over here because I didn't save the changes, which, let me rerun it once with so everything go as fast as possible. Okay, so let's run this again, and just going to refresh this page. Okay, So in this case, both finish pretty much instantaneously. Okay, so both APIs finish instantaneously, and then both display. So the sort of commented out codes over here essentially add a delay to make one or the other one slower. So in this case, I'm going to make the dictionary API. I'm going to first make the dictionary API slower. Okay, so I'm going to comment out this end request, and I'm going to uncomment out the one with the set timeouts, which forces a 5-second delay. And so this is used to show you that these functions essentially are running asynchronously. That is, they sort of split off and each does their own thing, and then later on they join back together when we get to the function terminate. Okay, so in this case the dictionary API should be much slower. So this one should take longer to display. Okay, so let's try a new term. Let's try doctors. Okay, so this is working, so you can sort of see the progress bar. Okay, and a second later, 5 seconds later, the results pop up for doctor. Okay, so that's sort of showing that that socket remains open until res.end is called. Okay, so you can sort of keep this socket open and send the data afterwards. So each of these, we have some CSS to place them into the correct location. In this case, USA jobs goes on the left, and the dictionary results goes on the right. Okay, so let's do the reverse now. So the reverse is that the dictionary is very fast, okay, and then the USA jobs is very slow in this case. Okay, so USA jobs should be 5 seconds later. Okay, so we'll search this again. So this time, doctor appears right away. Okay, and then 5 seconds later, the job should appear. Okay, so the point of this is to sort of prove to yourself that these are operating asynchronously, that they are sort of independent of each other, and only when they both finish does this terminate function get called. Okay, which how you can tell if the terminate function is called successfully is that when it calls res.end, before you call res.end, you'll have this sort of loading progress bar over here on top, and then when it finishes, it goes away. Okay, so that's one way to note that res.end was called. Let's see. So again, this pad start is mainly used because this doesn't work as well if there's not a minimum length. That's why I have to pad the strings a bit if they aren't long enough. Specifically, this string is generally not long enough. Not long enough to force the browser to start rendering right away. So I added a couple of spaces to make the string 1024 characters long, and then at that point most browsers will sort of display the result. Okay, so the next demo is the Todoist demo.